Greetings, geometry students. Welcome back to 9.4. Okay, hopefully 9.2 and 9.3, the surface area stuff wasn't too difficult for you, but it did present its challenges. So now we're going to change gears here a little bit. Now we're going to be looking at volumes. Okay, so volumes are a little bit different. Volumes, when you're talking about volumes, you're talking about three-dimensional. Okay, you're talking about actual physical space inside of an object or inside of a prism of some sort. So let's start here. So here we have a prism that is 6 units by 4 units by 2 units. Okay, so if we go for surface area, remember, will be perimeter of the base times the height plus twice the area of the base. Okay, so if I consider, I'll consider like this end piece right here to be the base, and it doesn't really matter overall because I could have chosen any side to be the base. I would still arrive at my answer the same way. So perimeter of the base would be 2, 6, 2 over here, and then 6 from up top. So that would be 6 plus 6 plus 2 plus 2. So 12, 14, 16 times the height. My height in this case would be 4. Okay, so that's going to be 64. Then twice the area of the base. So my area of my base would be 2 times 6 for a matter of 12. So that would be 64 plus 24. So that would be 88 units squared. That would be my surface area. Now the volume, let me change colors here. Volume is counting each one of these blocks over and over and over again until we're all the way through. And now would be your volume, okay? So if I count this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And then it's going to be the same on the bottom. So it's going to be 24 plus 24 for 48 units. And then for volume, I put units cubed, okay? And the way to remember that is units cubed because you're talking about three-dimensional space. Okay, so you're taking 24 plus 24. And the short way to do that would be 6 times 4 times 2. Okay, so this becomes length times width times height. That is how you figure out the volume of a prism. Length times width times height. Or another way to say it, this often becomes just the area of the base times the height. So volume of a prism is nothing more than just big B times H, where big B, recall, is just the area of the base. That's kind of it. So whatever shape the base is, you figure out the area of that, you multiply it by the height, that gets you your answer. How does that change for a cylinder? Well, for a cylinder, we know that my base is a circle. So if I follow that same idea, whatever the area of the base, whatever that is, times the height, but I know that my area is a circle. How do I figure out the area of a circle? Pi r squared, and multiply that times the height. That becomes my volume. So this is what you would put in your yellow sheet, in your formula sheet. Right there and right there. That's what I would put in there. Okay, so here we've got a triangular prism. Okay, so this would be my base. So my volume would be base times height. My base is a triangle. The area of the base would be 1/2 small b times h. So 1/2 12 times 10. So my area of just the base will be 60 centimeters squared. So for volume, I take that area and I multiply it by 11. So my full volume here will be nothing more than 660 centimeters cubed. Okay, be picky about that, because that's got to be raised to the third power. That's how you know you're talking about actual physical space. And remember, what I'm doing is figuring out all the space inside of here. Okay, I'm not just looking at, like, you know, this side, this side, this side, this side, adding them up. Basically, a volume, the way you want to think about volume is, if I'm going to fill this container with water, how much water can it hold? That's what I'm doing. How much water could it hold? That's what you're looking at for volume. So here, same kind of idea, only a little bit different twist. Once again, we have a triangular prism. Only now I have a slight problem. Okay, I've got the height of the prism, and that's 10. Figuring out the area of the base, you know, area of a triangle is 1/2 base times height. I've got 1/2. I've got 9 as my base. I don't quite have the height. Okay, the height is missing here, but I do know my hypotenuse. And if I've got a hypotenuse, then I've got two sides of a right triangle. Now it just becomes a right triangle Pythagorean theorem problem, really. So I get 9 squared plus h squared equals 15 squared. 9 squared is 81. I don't know why I wrote 9 there. 15 squared, 225. When I subtract those over, I get h squared equals 144. You know, subtract 81. That becomes 0. Square root, that becomes 12. So that becomes 12. So now my height becomes 12. So 1/2 times 9 times 12 is going to be 54 feet squared. 54 feet squared. So now when I multiply that, 54 times 10, my volume is going to be 540 cubic feet. Okay, this is often said as cubic. Okay, so that'd be cubic feet. So this prism below, so this is a pentagonal prism. Pentagonal prism. So for the area of a pentagon, so volume is still going to be area of the base times the height. So the area of a pentagon, if I look, each side is 5, and they're very generous in that they give us the apothem. Apothem is a vocab word from way back. So if I kind of consider this, remember, this is where we start breaking it up into triangles. Okay, realize that each one of these triangles is going to be the same size. So let me expand out this triangle. So this is 3.4, and this whole thing is 5. Write that a little bigger for you. So my area of one triangle would be 1/2 times 3.4 times 5. So that will be 8.5. But then realize I've got 5 triangles. So I'm going to multiply that by 5. So my total area of the base is going to be 42.5 square millimeters. Okay? So 42.5 square millimeters, 42.5 times 8, because 8 is my height, I get 340 millimeters squared. Oh, sorry, cubed. Cubed. My apologies, that should be a 3, because that's a volume. Okay, I'm hoping that this kind of makes sense. This is a good review of solving for the area of a regular polygon. But I wanted you to kind of recognize and realize that's kind of how we do that one. Okay, so now we change gears. So now we start looking at a cylinder. And if you recall, a cylinder is just pi r squared times the height. Okay, pi r squared because the area of a circle is just pi r squared. Okay, so I'm just kind of putting that all together. So I take pi times 3 squared times 8. Okay, so if I multiply out what I can, that would be 72 pi centimeters cubed. As a decimal, just do some calculator mashing, 226.195 centimeters cubed. Most of this is in the setup. Once you make sure that all those pieces are correct, then it just becomes a lot of calculator mashing. That's kind of all it becomes. And that tell me what you get. So here, this one presents a little bit of a challenge because this is 16, but that doesn't help us. We want this height. But if I look closely, this is a right triangle. So this would be a right triangle where this is 16, this is 10. I'm looking for this, okay? So I will use Pythagorean theorem. So that's going to be 256 equals 100 plus h squared. So that's 156 square root. Square root of 156 will be 12.49. So for volume purposes, volume is still pi r squared times h, so pi 5 squared times 12.49. So I'm going to multiply that together. I get 980.962 centimeters cubed. And if you go to 2 decimal places, that's usually pretty standard. That's usually fine. Make sure your rounding is good. Otherwise you could be a little off. But usually 2 decimal places is what's expected. So now here we have an oblique hexagonal prism. Okay, so oblique just means it looks like somebody came up and tried to push it over. But the general idea is still the same. Okay, this time they're very, very nice and they give us the area of the base. But your big idea is recognizing that this is my actual height. Okay, it's not like I'm taking a length from here to here. That's not a height. My height is straight up and down as close to the top and bottom as I can make it. So it just becomes 17.3 times 6.4. That's it. But you have to recognize that 6.4 is my height, not what any of those other lengths would be. That's kind of it. Recognize that this is my height. Last piece, so kind of a twist here. They have the same length and width, but different heights. Okay, so this is 4, this is 4. This would be x. This is going to be the same x. This is 7, this is 7. The volume of prism B is 150 cubic inches greater than the volume of prism A. What is the length of each prism? So if we consider what this is going to look like, okay, so the volume of this is going to be 4 times x times 7. The volume of this one's going to be 4 times x times 10. And this x represents, it's the same width, okay, or same length rather. They have the same width, 4, but now we just have different volumes, okay? So this would be 4x7, this would be 4x10, okay? So 28x and 40x. But now remember the difference. The difference is this prism is got 150 inches greater. What is the length of each prism? So now what is this going to look like? So let me slide this up. So this volume, this volume is 28x. This volume plus 150 equals 40x. Okay, so now what I'm representing is this volume, these two volumes, both represent the volume of this one. But remember, the volume of this prism is 150 bigger. Okay, so now a little bit of algebra, and I get that. Okay, so if I subtract 150 over, these two volumes are now the same, so I can set them equal to each other. So now now it's a couple step algebra problem. So that's 150. 40 minus 28 is going to be 12. So a little division. And x is going to be 12 and a half. So my length of these are both going to be 12 and a half. Okay, so now don't be confused by when I wrote this volume here, but then all of a sudden I add 150 here. Okay, so right now this is just this is just volume of B is 4 times x times 10. When I get to here, this is saying the volume of A plus 150, which is equal to the volume of B. Okay, so that's prism A, that's prism B. That's kind of how I set that up, okay? All right, if you have questions about this one, please come talk to me, because I know this one's a bit of a challenge, but it's workable. It's workable. You have to be a little bit clever, but you can still do it. Okay. All right, well, good luck. Make sure that you are very picky about your order of operations, and I would love to answer any questions you have. Thank you.